Hi, welcome to another Unity Mobile Dev from Scratch tutorial. This is part 2 of the Fruit Ninja recreation. In the previous tutorial, we looked at creating an apple and also splitting that apple with a swipe trail on the screen. Now we're going to create what I call an apple gun, which is our spawner for each apple to shoot it across the screen. So first of all, using the last project as a starting point, I've created a cube. Now you can't see this cube on the screen, but if I just zoom out of here, you'll see that it's just over here. So it's just off the screen as far as the camera is concerned, because this is where we want the apples to spawn from. Now you can use an empty game object as a spawn point. I like to use a cube because I can see its transformation, I can see where it is, and we're going to use the rotation of this cube to actually shoot the apples in that direction. And of course you can do that with an empty game object, but you can actually see it when you put a cube there. So this cube, what I've done is I've rotated it, and I'm going to use the cube's forward axis, which is the blue axis, to shoot the apples in that direction. Right, so I'm going to leave it on the screen at the moment so you can see it. Now, what I've done with this cube is add some script called Apple Gun, and I'll show you what's in that script. It's quite simple. Here it is. So all it's doing, it's taking in an exposed variable called apple prefab. Now in that we give it the single whole apple, and then it's going to invoke repeating every second this release apple function, which will instantiate an apple and then add a force to its rigid body. And that's all this is doing. So you just need to create this release apple. Now this force that you add to the rigid body of the apple will depend on how fast you want that apple to start flying across the screen. Now I've found in this point that multiplying it by 1000 seems to work quite well. So if you write that up and save it and add it to the cube, then select the cube. What you need to do in the inspector is make sure the apple prefab is set to your single apple. So grab the single apple prefab from here and drag and drop it over onto the apple gun. Now if we press play, we should see that the apples start to get instantiated from this cube and then spat out in that forward direction of the cube. So if you wanted them to go straight up, then you could just grab that cube, which I can show you while the game is actually running, and rotate it in a different direction. And you can see that it will influence where the apples are shooting. If you wanted to add different types of fruit, you could have different spawn points in different directions. Now, one thing I forgot to tell you is with the cube that I created as a spawner, I've actually turned off the box collider that automatically comes with it, and you could remove that altogether. If you leave that on, let's turn it on, it will influence the way that your apples are spawning and what they're doing, as you can see here, because it's actually a physics object and the apples have a rigid body on them, so it's going to cause a bit of an issue. If I turn it off, it then won't influence it at all. So if you're getting really strange things happen when you're trying to spawn things from your cube, remember that you have to get rid of the box collider on that, because we're just using it as a location and direction in space. It's now seems to be working okay as far as shooting them out, and then if we swipe, it also cuts them for us. Now you can tell at this point it's not perfect and we still need to make a fair few adjustments to it. The first one I would do is to actually make these apples a bit smaller. So that's quite simple, just by, if you control select each of the apple prefabs that are in the assets folder, then you can set their scale all at the same time. Remember, they're all from the same model, well, sort of, as we discovered last time, so they're all in the same sort of scale. So if I run that now at 0.5, we might get better sized apples and quarters and halves. All right, so that looks good. Now the next thing, as this keeps instantiating apples, have a look over in the hierarchy to see what's going on. Now this is going to instantiate forever, and when you start slicing things up, then you'll get even more little game objects going on. And this list will get longer and longer and longer. We don't want this to happen. In any game when you're creating a lot of game objects and they're going off the screen and then not being used again, you should make sure that you clean that up. And we can do that by making them destroy themselves when they go outside of the camera's viewing volume. Now, I'll just mention here that the better way of actually doing this is object pooling, which I have looked at in other tutorials, but I'm not going to cover that here. And we might do it in a few more videos time. But object pooling is a really good way of reusing the same assets over and over again so that you're not constantly instantiating and destroying things. Right, so let's destroy these things when they go outside of the camera. Let's create a C# and let's call that something like destroy me. And we'll open that up. Okay, now the function that we want to use is called void on became invisible. And that will get fired when an object that's visible and inside of the viewing volume of the camera becomes invisible or goes outside of the viewing. So on this case, when the object becomes invisible, we will destroy it. So destroy this dot game object. Now the important thing about using this function is it must be on an object that has a mesh renderer, because obviously an object can't become visible or invisible if it's not visible in the first place with a mesh renderer on it. So don't be fooled into just adding this onto any old game object and hoping that it will then disappear when it goes outside the viewing volume. Right, so save that. Let's go back into Unity and we want to grab hold of each of our prefabs. Now I'm just going to check at this point that we're putting it onto an object that has a mesh renderer, which we are for the half apple. So I'll put destroy me on the half apple. And the single apple, let's have a look. It's also got the mesh renderer and we'll attach the destroy me. Now, if I remember rightly, the quarter apple is a bit of a funny thing. So if you go and have a look over here at the quarter apple, you'll see that it's actually made up of smaller bits. Like it's got these poly surfaces in it. And it's this poly surface that actually has the mesh renderer on it. You can see there. Now, if we go ahead and delete this, it won't actually delete our quarter apple, it'll just delete this part of your game object, the poly surface. And you actually want to grab hold of the parent. So we probably need to just tweak our code a little bit to take care of the situation. Okay, so let's just modify destroy me. And this is what you need to change it to for your destroy function. Is that what you can do with Unity is you can actually get, rather than getting the parent that something is attached to, you can actually get the root object, which is the thing right at the top of your little hierarchy of game objects. So for that apple, for example, the root object is the top level quarter apple here. And any of these bits that are underneath this, if you say transform.root, it will get this one. Now, if these had sub-objects, child objects as well, and you put this code on them, then it would automatically just go all the way up to the top and grab your root object. So this is really handy to be able to get that very top level object. So we're going this .game object .transform.root. Now this is getting another transform. And then we're going to go .game object to make sure that we've got the game object that is belonging to this transform. Does that make sense? Hope so. Anyway, it does grab it. Okay, so that's the code. Save that. Now, it will still work quite happily on our other objects. If an object that you're trying to get the root of doesn't have a parent, then it will just return itself, so that's fine. So with your poly surface here for this particular apple, you'll need to add the destroy me code onto there, not onto this quarter apple, which doesn't have the mesh renderer. Right, so now if we run this, we can test out that on became invisible. If I can just cut up some of these apples. Now I've still got this cooldown on my swipe, I think at a second or something, which is probably a bit too long. But if you watch over here in the hierarchy as these objects come out and I cut them up, is that they get created and then as soon as they go off the screen, they start to disappear. Now the important thing that I'll also tell you when you're testing this is that on became invisible works for all of the cameras. So if I actually zoomed out like this, then you'll see that these apples aren't getting destroyed and they won't until they get outside of this camera as well. Okay, so you have to take into consideration all the cameras that are going on in your editor at the time that you're testing it. Otherwise you'll think, what? They're not disappearing, they're still going forever. But that's because they are actually still visible somewhere on your screen. Now the next thing we need to fix is that when we swipe an apple and cut it, as you can see there, the halves and the quarters just stop midair and then drop. Because what's happening is that although they have rigid bodies on them, there's been no force applied to them. The apples that come shooting out of the gun have a force added to their rigid body, but when we get rid of that and we create the halves and the quarters, they've got no force. They're not going anywhere. So they're just instantiated and then they just drop. So when we actually create those apples at the same time for the quarter and the half, we want to transfer the velocity of the single apple onto those other objects. So in Swipe Trail, okay, I just go, this is the top of Swipe Trail, and in our update function, which is now getting quite large, go down to the section where we're adding in our whole apple to be cut and our half apple to be cut into the quarters. While I'm in here, I can actually see, here's my invoke cooldown thing of 1 second that I said was annoying me. I'll just set that down to 0.5 for now. All right, so in here, we're going to add these lines that I've got commented out. And I'll just leave them commented out so you can actually see them a little bit better at this point. But what they're doing is they're getting the velocity of the object you've just created and setting it to be equal to the velocity of the object that you have swiped, okay, which is our G-obj. And that will keep it moving in the same direction. So if I just uncomment that, that's for the first half that gets created, and then there's a second half here. And then when you cut a half in half, you get quarters, so you get 2 quarters, and the same code for that there. So H1 and H2 all need to have these velocities transferred to them. So save it, go back into Unity and run. Oops, got an error, which is my typical error I always get from not putting an F on the end of my floats. Okay, save that. Let's run. And now when I cut things, you'll see that they keep moving in the same direction. As a final touch for this tutorial, what I'd like to do is when I swipe over these apple pieces, is that I want some of the swipe movement to translate to the actual apple itself. And we could do that by putting a little bit of spin on the apple pieces and also possibly a bit of force. So if I push like in this direction, I want that force to translate onto the apple and sort of slow it down from moving this way, and being able to push it downwards as well. So to do that, you need to work out the change in position of the drag. So if we start there and we drag down this way, then obviously the vector is going to be in this downwards direction, and we want to apply a downwards force to the apple. Now we're drawing on the screen, so we have to remember that, But what is in the world space is the actual swipe trail itself. So if we use the positions of the swipe trail at the time we touch and as we drag over before the next update, then we can actually apply a vector from that to our apple. Okay, so let's just go back into the code where I've already added this for you. Let's go up to the top first of all, and we need to add in two variables. We need a last position and a delta position. So you have to actually calculate what the vector is that your swipe is moving along. And let's just go like this to uncomment them. So the last position will be a record of where the mouse was, or the swipe was, or your finger touch, whatever, in the last update frame. But the delta position will calculate the difference between where your finger is now in the world and where it was in the last frame, and that gives you your vector that you want to apply. Now the application of that vector, which is further down, before we actually apply it, we need to calculate it. So just inside of the if statement, after you've worked out where your finger is hitting the plane and all of that, and you've calculated the mouse ray, before we do the ray cast down here, we're going to calculate the delta position, which will be the current position of the swipe minus its last position. And then once we've calculated delta position, we'll actually update last position to the current position of the mouse, so that next time we come around, it'll give us this, where last position is the last position of our finger touch in the last frame or the last update. Right, so the delta position is now the vector in the 3D space of the direction that we want to apply to our apple. So down where we actually create our halves and our quarters, these are the lines that I've commented out here that we're going to add. So the first line for each piece adds a torque. And a torque, it adds a spin basically onto the object using that delta position vector. And I've ramped it up a bit, so multiplied by 1,000 here. You can try these out for different types of forces. And then the second line you want to add is a force to the object using the delta position vector again, and I've multiplied it by 500 this time. I had it at 1,000 and that was pretty fast, so you probably don't want to do that. Now these two lines are added in after you've set the velocity for each object. Okay, so it's exactly the same thing again for the second half. Add torque, add force, and then it's the same for each quarter. So add torque after the line with the velocity setting, and then add torque and force for our second quarter. Right, so save that. Then back to Unity. Let's have a look at what we've got now. So when we swipe our apple, you can see I actually can push this down, and it will swipe. Oops, there's a few funny things that I'll explain in a minute. You see that the swipe, if I just do a short one, it's also adding rotations to it as well. Now, you will now occasionally see that an apple will just unexpectedly fly up and off the screen. Now, this is because I'm using the mouse in this case and not a touch, because the mouse will actually register as soon as it hits. So if I just click on this, that code is going to fire. When you're on a mobile device, because you've got that code that says touched, where is it? Let me show you. Touch phase dot moved here is that this isn't going to fire unless you've actually moved, but this will fire even when you just do a single click. So you're not seeing the exact results as it would be on a mobile device. So to fix that problem, you need to add another little update that kind of resets the last position when you first touch the screen or put the mouse down, because the last position needs to be calculated while the finger is still down and moving across the screen. And then when you release your finger, you want the last position value, this one here, not to be used immediately when you touch the screen again, because you might have last touched the screen like over here. You've lifted the mouse up and then you're doing something over here, and then you'll get this huge vector calculated like that, which you don't want. To fix it, we'll add another if statement above the first one we've got there for moved, but we'll now test that we've just touched the screen for the first time and reset last position. So I'm just going to add some code here. So this is the code I've added. Now this if statement is again testing for touch count greater than 0, but it's doing a touch phase of began, and it's also testing that the mouse button is down. Okay, so this will register when you've clicked, whereas get mouse button here, this one will register for the whole time your mouse is being held down, but this only happens for one frame. Right, so this is the same code as far as touching the screen and getting the position that you're touching the plane that you want to touch at the back of the screen in this case. And you'll see that I'm converting that ray touch value to the last position. And that's where last position is actually getting set for the very first time, is when you first touch the screen. So that anywhere you last touch the screen will get removed in the new calculation for your ray. So save it and switch back to Unity, and then when you play you won't get that weird problem of the apples flying up the screen in the wrong direction. I tell you what, I'm pretty rubbish at this game, aren't I? Anyway, so you can modify this as you like. You can increase the speed at which the apples come out. You can change that cooldown on the swipe. You can change this apple speed, rotation, direction. All those sorts of things are completely variable. So have a little play around with it and see what you can do. And also look at different objects that you can find that you can also cut up. It doesn't have to be apples. It's just that I had that model, so it was more convenient. Alright, so that's the end of this tutorial. In the next tutorial, I'll actually start showing you how to do scores that appear on the screen and float up and then fade out. And I'll also then apply it to this game here, so you can see how a sort of a scoring mechanism might work.